Chapter 2, Exercise 7. Hints. For Part A, use definition 218 and theorem 220 to prove that for any sets E1 to En, the equality here holds. For Part B, show that this for each I in n. For a counterexample, refer to example 221e. Solution. A. First, we will verify that for any sets E1 to En, we have this. If x in Ej prime for some j in this, then every neighborhood of x contains infinitely many points of Ej, theorem 220. From the inclusion here, it follows that every neighborhood of x contains infinitely many points of this. Thus, since this holds for every j in this, we conclude that this. We will now prove the reverse inclusion by contraposition. Suppose this, meaning that x not an element of ei prime for every I in this. Our goal is to show that this. Since x not in ei prime, there exists Ri greater than 0 such that this is finite. Let R equal this. Note that R greater than 0. Since this, the set here, is finite. Taking the union of these sets, we find that this is finite, hence this. Thus, this, proving the equality here. Now, by the definition of closure, definition 226, Bn bar equals this. B. Since ai subset of B, for every I equals 1, 2, and so on, it follows that ai prime subset of B. Indeed, let I element of natural numbers and x element of ai prime. Then every neighborhood of x contains a point from A which is distinct from x, and consequently it contains a point from B which is distinct from x, since ai is subset of B. Hence, ai bar equals this. This inclusion holds for every I element of natural number, so this. Now, let us show that this inclusion can be strict. Consider the sets ai equaling this for I element natural numbers. Each set ai is closed since ai bar equals this. See the corollary to theorem 220 and theorem 227b. Hence, we have this. On the other hand, b equals this, and 0 element of b bar. See example 221e. Thus, b bar does not equal this. Red points are AIs. Note that 0 is a limit point of b equaling this that does not belong to b. Comments. This exercise tells us that the mapping closure is distributive with respect to finite unions in P of x, but not with respect to arbitrary unions. Thanks for watching.